Alright, here we are at topic 4, trig functions for any angle in the unit circle. And unfortunately I do not have a copy of my unit circle with me, so I will work on this without it and see how that goes. A point 2, -11, so that's going to be in quadrant 4. So if I go to the right 2 and down 11, there it is, 2, -11. And then the reference triangle is always, if I drop a perpendicular to the x-axis, so that tells me where theta is. It's inside the triangle. So here we have -11, here we have 2, and we need to find the missing third side of the triangle. So I'm going to do 2 squared plus -11 squared, and that's going to give me the square root of 125. So that's my hypotenuse, or my radius. So I'm going to so 125 is 5 times 25, so if I rewrite it times like this, and I can think of square root of 25 is 5 radical 5. So that's this side right here, 5 radical 5, and my radius is always positive. So when I do sine, I'm going to take opposite over hypotenuse, so that's going to be -11 over 5 radical 5. Rationalize the denominator, multiply by radical 5 over radical 5. I get -11 over radical 5 times radical 5 is 5, times 5 is, wait, that was -11 radical 5 over 25. And the cosecant, I can just flip-flop my sign, and I'm going to flip-flop this one because it has a radical on the bottom, and that'll put 5 radical 5 over -11. Then for cosine, I'm going to do 2 over 5 radical 5. That's ka, so we have so, ka, toa. So adjacent over hypotenuse, so that's 2 over 5 radical 5. Rationalize, I get 2 radical 5 over 25. And then I'm going to flip-flop and get 5 radical 5 over 2. Tangent is opposite over adjacent, so that's -11 over 2, 2 over -11. In number 25, if cosine of theta is -6/7 and sine theta is less than 0, find the exact values. So here's where I have to figure out which quadrant is it in first. So here's where all students take calculus, and that's what tells us what is positive in each quadrant. So here I want, so here I've got sine is positive, tan is positive, cos is positive, and then they're all positive here. So I'm going to just fill in, if sine is positive, the other two must be negative. If tan is positive, the other two must be negative. If cosine is positive, sine and tan must be negative. So here I'm looking for a negative cosine and a negative sine. So the quadrant where that happens is quadrant 3. So now I can draw my angle or my triangle in quadrant 3. So I'm going to go ahead there, drop my perpendicular to the x-axis, there's theta, and then the cosine is -6/7. So that's adjacent over hypotenuse. And then I'm going to figure out what the missing third side is. So I've got -6 squared plus y squared equals r squared, which is 7 squared. So I'm going to do 49 minus 36, and I get y squared equals 13. So my missing side must be the square root of 13. And then because it's in the third quadrant, it's negative. So now that I have my missing side, I can go ahead and find all my trig functions. So the sine is opposite over hypotenuse, negative radical 13 over 7. Cosecant, I have to flip that, so I'm going to go 7 over negative root 13, rationalize by multiplying by root 13, 7 radical 13 over negative 13. And the negative can be in the top or the bottom. Alright, the cosine was given, negative 6/7, so I can flip that. And then the tangent is going to be negative radical 13 over negative 6, which just negative over negative makes it positive. And so then I'm going to flip that to get the cotangent and rationalize. I get 6 radical 13 over 13. Last but not least, find the reference angle for each of the following. You need to be able to picture where this angle is, and then figure out what's the relationship between that and the x-axis. So you don't have to draw it, you just have to be able to picture it. So 164 is over here, so that tells me I'm doing 180 minus 164. I get 16. And then negative 461, if you're like me and you have a hard time picturing where that is, you can find a coterminal angle with it. So let's see, I'm going to play with my light here. Is that better or worse? Worse. Okay, so there's just a little bit of a glare on the page. Negative 461, I'm going to go ahead, I'm going to just add 360 to it so I can picture it easier. So negative 461 plus 360 is what? 101? Negative 101? And then if I really want to picture where that is as a positive, I can add 360 to it again. So remember, I'm just doing what I personally need to do to be able to visualize and picture where that angle is. So negative 101 plus 360, that's 259. Okay, but reference angles are between 0 and 90, because, what did I say that was? 259. Yeah, 259. Okay, let me write that down. So, reference angles are between 0 and 90 because they have to fit inside of a triangle. Knowing this number just helps me picture where it is in the universe. So 259, I know here's 180, and here's 270, so if I get to 270, I'm gone too far. So here's 259, so I can do 259 minus 180 to figure out what the reference angle is. So that is going to work out to be 79. That's the answer there. Okay, so in class we've spent a lot of time figuring out, okay, negative angle, and we would have gone the other way. We would have gone, okay, here's 360, here's another 101, and I would have been trying to figure out where this is, and then still had to find the reference angle. So here I just approached it slightly differently. Negative 3/4 pi, I could use my unit circle to look at that and so since I can picture that without doing anything crazy, I can just go negative 3/4 pi is right here. But if I wanted to find the reference angle, I could add 2 pi to that. So negative 3/4 plus 2 is 5/4. Okay, so 5/4 pi is where it's located, but that's not the reference angle. The reference angle is just how much of that is between there and the x-axis. So I would subtract pi, because that's where that is on the x-axis. So 5/4 pi minus pi is just 1/4 pi, or pi over 4. And then 13/9 pi, I'm doing what I need to do to be able to picture where that is. And so 13/9, I'm going to change it into a mixed number just for a minute so that I can know where it's located. 13/9 is 1 4/9. So 1 whole pi is here. 4/9 more pi is, let's see, does that make it all the way here to 3/2 pi? Is that as big as 1 1/2? No, it's in here somewhere. Okay, and it's probably pretty close to 3/2 pi. So I don't have to know where it is exactly. I just need to know where it is so I can know what to do. So to get the reference angle to figure out where it's closest to the x-axis, I just need to subtract pi. So 13/9 pi minus pi, or 9/9 pi, it gives me 4/9 pi. Alright. Got a few more questions. These are give the exact value. So these are unit circle questions. So in order to answer these questions, I'm going to figure out exactly where this angle is on the unit circle. Since I don't have my unit circle in front of me, I'm going to, in my head, or just make a quick sketch. So -4/3 pi, I know there's 6/3 pi in the whole unit circle. So if I go -4/3 pi, I'm going to end up right here at 2/3 pi. So I'm looking at my unit circle, and I'm taking the sine of 2 pi over 3. That's a coterminal angle, so it's going to be the same. The sine, well, let's talk about what is the ordered pair at 2 pi over 3. On my unit circle, it should be -1/2 radical 3 over 2. That's the ordered pair at this angle. And then when I'm asked to find the sine, that's going to be the y-coordinate. So there it is. Now 7/6 pi, -7/6 pi is going to be on the unit circle, going in a negative direction. It's going to be also in the second quadrant, but it's going to be at 5 pi over 6. So the coterminal angle with that is 5 pi over 6. So I'm picturing what is the ordered pair at 5 pi over 6. That's the coterminal angle. The ordered pair over there is negative radical 3 over 2, comma 1/2. So I'm looking for secant, which is related to the cosine. So here's my cosine. That's my cosine, because it's cosine comma sine. So now I've got to flip negative radical 3 over 2. So I'm going to go and just get a little extra workspace here. 2 over radical 3, and I'm going to keep my negative sign. Then I'm going to rationalize, and I get -2 radical 3 over 3. And that is my secant at that angle. When I go to 7/4 pi, that is in the fourth quadrant, 7/4 pi right here. So on your unit circle, that's going to be, so I know all the fourths are radical 2 over 2, radical 2 over 2. And then in the fourth quadrant, it's my y, that's negative. So I am looking at my cosine, so I'm going to take my x coordinate. And then to do cotangent at pi over 6, I am looking at the angle pi over 6, that's in quadrant 1, and I know that the ordered pair right there is root 3 over 2, comma 1/2, and I've got to divide y divided by x. So 1/2 divided by radical 3 over 2, so 1/2 divided by radical 3 over 2 is times 2 over radical 3. I get 1 over radical 3, and so I know to rationalize that, I multiply by radical 3 over radical 3, and final answer, radical 3 over 3, and that's positive. Oops, that's the tangent. I found the tangent by doing y over x. I should have done x over y to find the cotangent, but now that I have the tangent, I can take the reciprocal. So here, I'm going to take the reciprocal of this guy, and I'm just going to flip it over, and I get radical 3. That's the cotangent. Sorry about that. Alright, I'll make a new video for topic 5.